This video is about benzene. In this video, you can learn what is benzene, the structure of benzene, shape and bond angle of benzene, the phenyl group, arenes, reactions of benzene. Benzene is an aromatic hydrocarbon. It has 6 carbon and 6 hydrogen. Here, if you see the structure, the carbon and hydrogen single bond. But carbon-carbon bond here, already I have shown 3 bonds of carbon and 1 is left still. If you see the electronic configuration, 2pz electron is left. This 2pz electron can make pi bond with beside carbon. Similarly, 3 pi bonds can be possible. So if you see here, but these pi bonds are not fixed. Structure of benzene. This is the structure of benzene, that is skeletal structure, but the pi bonds are not fixed. The alternative pi bonds we can show here. So the pi bonds are rotating, so this is called delocalized electrons. Now, shape and bond angle of benzene. If you see the structure of benzene, it has 6 carbon and they are in the same plan, and this is the uniform structure, so this is called planar hexagon. Since the hexagon is uniform and the carbon-carbon bond length are equal, so the bond angle is 120 degree. Now, phenyl group. From benzene, if hydrogen is missing from here or hydrogen is disconnect, so we get a group that is called phenyl group. We can show here carbon is total 6 and hydrogen is 5, so this is called C6H5. This is also called benzyl group or aryl group. Now, arene. Benzene is the simplest arene. Also, we have methyl benzene. This is nitrobenzene, phenol, benzoic acid. These all are arene. We can write many arenes. Reactions of benzene. The main reactions, 2 types: addition reactions, electrophilic addition, and hydrogenation of reactions. Hydrogen can be added with the double bond, and the chlorine can be added there. But depending on the conditions, another type of reactions, substitution reactions. Hydrogen from benzene can be substituted by different group. They are chlorination, bromination, nitration, and sulfonation. Now, detail about the reactions. Hydrogenation of benzene to form cyclohexane. In this reaction, this is electrophilic addition reaction. The reagent is hydrogen gas, and the condition nickel catalyst, temperature 150 degrees centigrade. In this reaction, the pi electrons of benzene attracted towards the electrophile, and it is making 1,3-hexadiene, that is 1 bond. In the 1 bond is missing. Another hydrogen is added, so another bond, double bond is missing, and finally we are getting 3 double bonds are gone. So we are getting a cyclohexane. There is 6 hydrogen atom or 3 moles of hydrogen added with the benzene and making cyclohexane. Addition reaction of benzene with chlorine. If you see here, this is electrophilic addition reaction. Reagent is chlorine gas, condition ultraviolet light and heat. In this reaction, pi electron from benzene are attracted towards the electrophile and making the compound. And again, another chlorine mole, another 1 mole of chlorine gas is added there, and finally the third mole of chlorine gas is added, and we are getting hexachlorocyclohexane. The position is 1 2 3 4 5 6 hexachlorocyclohexane. Now, substitution reaction. The first reaction, substitution reaction of benzene with chlorine. This is called chlorination reaction of benzene. This is electrophilic substitution. The reagent is chlorine, and the condition Lewis acid catalyst like aluminium bromide. In this reaction, chlorine and aluminum bromide react and make chlorinium ion. This is the electrophile. The pi electron from benzene attracted towards the chlorinium ion, and it is making the complex. This is the unstable one. Hydrogen ion is losing from here, leaving electrons and getting chlorobenzene. And H plus from here reacting with AlCl4 minus and making HCl and the catalyst AlCl3. The overall reaction, if you see benzene plus chlorine, presence of aluminum chloride, we are getting chlorobenzene and HCl. Substitution reaction of benzene with bromine. This is just like chlorination reactions. So this is electrophilic substitution reaction. Reagent is bromine gas and condition Lewis acid catalyst aluminum bromide. Aluminum bromide and the bromine gas reacted and making the bromonium ion. The pi electron attracted towards the bromonium ion and making the complex. This is unstable, so hydrogen ion is losing from here, and we are getting bromo, benzene, and hydrogen ion. This hydrogen ion reacted with AlBr4 minus and getting AlBr3 and HBr. The overall reaction, benzene plus bromine, and presence of catalyst aluminum bromide, we are getting bromobenzene plus HBr. Now nitration reaction. This is the most important reaction of benzene. This is nitric acid plus benzene reaction. In this reaction, electrophilic substitution reaction, reagent is concentrated nitric acid and conditioned sulfuric acid and temperature 55 degrees centigrade. In this reaction, first catalyst and nitric acid react and make nitronium ion. This nitronium ion is electrophile, so pi electron attracted towards the nitronium ion and making a complex. This complex hydrogen ion is losing from here, leaving electrons, and it is getting nitrobenzene. This is the main product, and H plus from here reacting with hydrogen sulfide and making sulfuric acid. The overall reaction, benzene plus nitric acid. In presence of sulfuric acid, we are getting nitrobenzene plus water. The last reaction, substitution reaction of benzene with sulfuric acid. This is called sulfonation reaction. This is electrophilic substitution reaction, condition heat, and the reagent is concentrated sulfuric acid. In this reaction, sulfuric acid broken down to sulfonic acid group and OH minus. This is the electrophile. The pi electron attracts electrons are attracted towards the electrophile and making the complex. Hydrogen ion is losing, and the delocalized ring of benzene is regenerated and getting the benzene sulfonic acid, and the H plus and OH minus making water. The overall reaction, benzene plus concentrated sulfuric acid, we are getting benzene sulfonic acid plus water. In this video, if you have learned anything, please like this video and share this video to your friends. Thank you very much.